Basic home electrical. Every day is started with the flick of a light switch. Electricity is at the heart of almost everything we do on a daily basis, from the car we drive to prepping the food that we eat. Electricity is everywhere. In modern society, we depend on electricity to make our lives easier. With some electrical basics, you will have the basic understanding of how electricity works and what it does. Electricity, what is it? AC alternating current is electric charge that periodically reverses direction. Alternating current is produced by generators, turbines, nuclear reactors. They make steam to run a turbine. And common voltages that are encountered in this are 24 volts AC, 120 volts AC, 220 volts AC, and also 480 AC. AC power is used in the residential and manufacturing. It's what powers our homes and our offices. DC electric current is the unidirectional flow of an electric charge. The charge basically moves in one direction only, and the direct current is always stored current. So it's batteries, solar cells, dynamos. Direct current is commonly found in these voltages. 1.5 volts DC, 3 volts DC, 6 volts DC, 12 volts DC, and 24 volts DC. DC power is used in automobiles. It's stored inside the battery. Portable electronics, campers, cell phones, computers, electric crank radio, or flashlights. Common measurements and tools for reading electricity. A voltmeter, what does it do? A voltmeter basically is a series of circuit boards that can take readings from powered or unpowered sources. Common readings can be collected in these formats. Volts DC allows for measurements in DC volts. Volts AC allows for measurements in AC volts. This is just off of a power cord, 122 volts AC. Milliamps is a measurement of current through a faulty switch or motor. Ohms gives the ability to check the amount of resistance against the current, like a switch or a motor or anything that comes to mind when electricity is used. Amps are the amount or current load, for an example, a light bulb or a coffee pot, or for instance, I have a toaster set up right here, and I will plug it in and turn it on, and we can read the amount of current that is flowing through the line right now, and it is 0.1, so it's not very much. Get some 0.6, 0.5 in there as well. There's other tools. An oscilloscope. Oscilloscopes are used to observe the change of an electrical signal over time. The signal is commonly referred to as hertz or Hz. Oscilloscopes are commonly used in the fields of engineering, the medical field, electronics industry for fine-tuning circuit boards and drive motors. An interesting fact about oscilloscopes is that they are commonly seen as a common seen form of oscilloscope is in the form of an EKG machine in a hospital. It also stands for electrocardiogram. An electrocardiogram basically reads electrical impulses of the heart. There's another tool called a VoltAlert, which I have right here. This is available in many sizes. It's a common tool to check for live wires, also known as a widowmaker. It is a slang term because it's known to lie if a user does not zero it in before use, resulting in the possibility of the user touching a live wire. It works by sensing electricity and electromagnetic field around a wire. This one has died, of course. But usually it lights up just like this. For some reason it doesn't want to work. It senses the electricity by the electronic magnetic field that comes off of it and allows the user to check for a hot wire without coming into contact with it. Fuses and circuit breakers. Fuses and circuit breakers are used to control the amount of current in an electrical circuit. When too much current travels through a line, it trips the breaker or the fuse. Switch breakers, they look like this. They're commonly found in residential homes and businesses. This is a very, very large one. These can accommodate from 1 amp to a million amps. Modern types uses a push button or a flip switch method to reset. This one does have that. Fuses are commonly found in old homes. Small electronics, or in vehicles. Older vehicles will sometimes have circuit breakers that will automatically reset with the time and this power source is shut off. The mechanical means to accomplish what it does is it creates a mechanical means to accomplish the cut of power is by overheating a metal element in the inside, causing it to burn away with the break of a contact, thus stopping the flow of electricity. There are common fuse types. There's a blade or a spade. I have a very large one here. This is for 300 volts DC or 600 volts AC. I have a time delay fuse. Don't have a thermal, but I do have a bus and a spade type fuse here. Electrical circuit. An electrical circuit is a path in which electrons from voltage or current source flow. There are two distinct types of circuits. There's a parallel circuit and a series circuit. In a basic term, an electrical circuit is switches or loads, light bulbs, heater elements, or the way that they're wired together. A series circuit. A series circuit is one with all loads in a row. There is only one path for the electricity to flow. If the circuit was a string of light bulbs and one blew out, the remaining bulbs would turn off. So this is a series circuit right here, and as you can see, the battery positive comes across and goes down back into the battery. So if one of these lights goes out, it breaks the feed means for the electricity to pass through. An example of a series circuit is Christmas lights. That's why when one bulb goes out, they all do. This is a big downfall for this type of circuit. Parallel circuits. A parallel circuit is one that has two or more paths for the electricity to flow. The loads are parallel to each other. If the load in the circuit were a light bulb and one blew out, there is still current flowing to the others because they still have a direct path from negative to positive terminals of the battery. I have a diagram right here, an example of that too. This is simple household lighting. So you got power coming up, feeding each bulb right here. Comes back, and so if you knock one of these out, it only burns one out. The other two stay lit, so the source is still contained. With a little basic know-how, any person with a little time can understand the basics of electricity. Before working on any appliance, make sure that the power is unplugged. With these basics discussed, you will have a little electrical knowledge and can save you costly appliances and save you money in the long run by not having to call an electrician.